Yeah, so we'll be doing application to emphasize on the second question of 11.1. Okay, we are going to do 11.1. There's only one exercise, so I'm going to start with the second question. The first question I've already explained in the previous video. Second question was not clear, so I'm going to explain that. So here what happens is that there is a tree, and this tree breaks due to a storm and falls down such that the top touches the ground. Okay, so this was the tree breaks and it forms the hypotenuse of this right angle triangle. Now if we look at the question is to find out what is the height of the tree. So the height of the tree is this. We can assume this part as x and this as y, and the question is to find out this height, and it is given to you that this angle that is being formed by the tree, the broken part when it touches the ground, is 30 degrees, and this is at a distance of 8 meters. Okay, the foot of the tree to the point where top touches the ground is 8 meters, so this is 8. Now what is interesting here is that this portion has fallen down, and therefore this is y, so the hypotenuse here is y. So how do we do this? So first thing to note here is that the base is given and we need to find out the perpendicular. So we are going to take this triangle, we can name it as A, B, C, D. The triangle is of course ABC. So in triangle ABC, we can use tan 30. Tan we are using because the base is given and we need to find out the perpendicular. So tan 30 is equal to x upon 8. Now the value of tan 30 we will substitute 1 by root 3. Cross multiply this, we get root 3x is equal to 8. So the value of x will be 8 upon root 3. So we get the value of x here. Now we proceed further. Here the base is given and we have to find the hypotenuse. So which trigonometric ratios connect base and hypotenuse? That is cos. So we are going to use cos 30 is equal to the base by the hypotenuse. Substitute the value of cos, cross multiply. So we get the value of y as 16 upon root 3. Now as explained in the figure, the height of the tree is x and y together. So we are going to find the total height now. Total height of the tree is going to be x plus y. So height will be x we have already found out as 8 upon root 3. Y we have found out as 16 upon root 3. Denominator is same, so we can add this. We get 24 by root 3. We'll rationalize this, multiply and divide by root 3. So height will be 24 root 3 upon 3. So height will come 8 root 3 meters. Okay, so 8 root 3 meters is the height, and as I have explained that if you need to calculate this in decimal, the value of root 3, please note, is 1.732 and root 2 is 1.414. These are the values which you should remember. In case in the exam they ask you to find in decimals, you can multiply 8 into 1.732 and get the required answer. So I hope this question is clear. We move on to the next question. So 3 I have already explained to you, 4th I have explained, 5th I have explained. I'm going to the 6th question. So here the question says there is a 1.5 meter tall boy and he is at some distance from a building. The height of the building is given 30 meters. Now what happens, he is watching the building with some angle, then he moves closer to the building and this angle changes. So initially he is at point A, he moves closer to B. Let us name this as A, B, C, D, and let this be E and F. So as per the question, the height of the boy is 1.5. So this boy is 1.5 meters. The height of this building is given 30 meters. Initially, when he watches the building, that angle is 30. He moves closer, that becomes 60. So this I had already explained that as we move closer, the angle will increase. Question is now find the distance that he has walked. In other words, we have to find out the distance from A to B. So first thing to note is that this figure that you find here is a rectangle. So this is 1.5. So this portion is also going to be 1.5. So this distance CD is going to be 30 minus 1.5. So we get this as 28.5 meters. So this distance is 28.5. So for calculation purpose, we will not be using 30 because 30 is not part of any triangle. 28.5 is part of the triangle. So what we are going to do, we are going to take the triangle BCD first. In triangle BCD, this is 60 degrees. So we'll use tan because the perpendicular is given. We can find out the base length. So tan of 60 is equal to 28.5 upon the base BC. Tan 60 is root 3. Substitute that value. Cross multiply. So we get the value of BC as 28.5 upon root 3, which we can rationalize. We get 28.5 root 3 divided by 3. So the value of BC is 9.5 root 3 meters. So this distance we have found out as 9.5 root 3. Now let's take the bigger triangle, that is triangle ADC. We're going to take the triangle ADC. In triangle ADC now, we will use tan 30. This angle here is 30. Tan 30 is perpendicular by base. So that's 28.5 divided by the base length, that is AC. Put the value of tan 30, 1 upon root 3, that is 1 by root 3 is 28.5 upon AC. Cross multiply, we get AC is equal to 28.5 root 3. So here we get the value of AC, here we have got the value of BC. Now the question is, what is AB? The distance that the boy has moved. So AB from the figure is AC minus BC, right? This is AB, and this distance AB can be found by subtracting the total AC minus this portion BC. So AC minus BC will give us AB. So both these values we have found out, we can substitute it. This will become 28.5 root 3 minus 9.5 root 3. So answer we'll get 19 root 3 meters. So final answer we'll write the distance that the boy has moved is 19 root 3. And as in the previous case, I had explained that if you want the answer in decimal, you may convert this root 3, substitute the value as 1.732 and multiply with 19 in case you want to get the answer in decimals. Moving on to the 7th question now. From a point on the ground, the angle of elevation of the bottom and top of a transmission tower. Now, transmission tower is on top of a building. Transmission tower is like a mobile tower. Okay, it gives signals. So here, there is a transmission tower on top of the building. This is the building. There is a transmission tower on top of the building. And from a point on the ground, when you are observing this, the angle is 45 degrees. But when you're looking at the top of the transmission tower, that angle has changed to 60. Right? So this angle here is 45. And the total angle when you observe on top is 60. So let us take this as ABCD. That's up to you. You can name it any way you want. The height of the tower is unknown. The transmission tower this height is given to you as 20. We have to find out the height of the transmission tower. Okay, so this is the transmission tower. We have to find out this unknown height. So let us assume that this is H. So what we need to find out is this. This is the building. Okay, and this is the transmission tower. So building height is given. This is the height of the building, and this is the transmission tower on top of the building, which we have to find out. So how are we going to tackle this question? So first I'm going to take the triangle ABC. I'm going to use tan 45. Let the base of this be x. So tan 45, I'm taking this triangle ABC. So tan 45 is perpendicular by base. So we get 20 upon x. So value of x, we get 20. Then I'm going to take the triangle ABD. Remember, we have to take all right angle triangles. So when we take triangle ABD now, we get tan 60 is equal to h plus 20 upon x. Because this height is h and this height is already given to us as 20. So h plus 20 upon the base is x. Put the value of tan 60, root 3. So h plus 20 upon the value of x we have already found out here as 20. So I'm going to substitute that here. Cross multiply, we get 20 root 3 is equal to h plus 20. And we're going to transfer this 20 to the other side. So what happens is this 20 root 3 minus 20 is equal to h. And therefore, what is the final conclusion? H is equal to 20 common, root 3 minus 1 meter. So here we get the final answer that the height of the transmission tower is root 3 minus 1. So hope this is clear.